Isn't that right? Isn't that right, Mr. McLaughlin? Isn't that, tell the people. Tell the people what they want to hear.
I may change.
No. Hey, where's your sling? Did the doctor say you can take it off?
What does it matter?
Did he say you can take it off?
Yes, you said I can take it out.
Are you lying?
I will not lie to you.
Pinky promise?
I don't need to.
Because you're lying.
I'm not.
Yes, you are.
He said I could take it off.
Well, how much did he put some limitations on that? Yeah, you're not telling us.
No. He said he could take it off in 4 more months.
Yeah, alright. No, it feels pretty good.
Yeah, it felt pretty good until Miss Day poked it when you broke it, didn't it?
Alright, let's go ahead and pray. Dear Heavenly Father, we just thank you for the day, thank you for the blessings you've given us, thank you for the students here. Just pray you help us in this class, in Jesus' name, amen. Alright, so I'm still working on your test. It takes me a little while because I have to go through each one.
I put 3 pi over 2 as sine equals 0 for all of it, and it was pi. And I'm sorry. I did everything right until I put that.
Alright, and that's what I look for. I look for things like that. So today we want to talk about the law of sines. Our trigonometric values are values that deal with right triangles. And we can find pieces of the right triangle through our trigonometric values. But what if it's not a right triangle? If it's not a right triangle, then we have some other methods that we can use to be able to calculate the sides of a triangle and the angles of a triangle. Alright, so the law of sines is one of them. The law of sines, basically in any triangle, is the sine of A over A equals the sine of B over B equals the sine of C over C. The lowercase letter is always the side opposite the angle. So when we look at this triangle, and again, it's not necessarily a right triangle. And this is what the letters would look like. You have our angles, capital letters are angles, lowercase letters are our sides. A, B, C. Notice B is opposite capital B, lowercase c is opposite capital C, lowercase a is opposite capital A. So this represents any triangle. Doesn't matter if it's right, obtuse, acute, this represents any triangle. Alright, we have this law, sine A over A equals sine B over B equals sine C over C. We are able to use this anytime that we have angle, angle, side, angle, side, angle, and side, side, angle. Side, side angle is the one that a lot of people get confused at. But angle, side angle, 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 side, and angle, side angle, there's only one possible triangle that we could possibly do with that. Take for instance, angle, angle, side. That's 2 angles
On one side.
and one of the sides. So if we know 2 of the angles, well, there's only one possible angle that the third angle can be. Because angles of a triangle add up to equal 180 degrees. Same thing with angle, side, angle. You got 2 angles, we know 2 angles, so there's only one possible angle for the third angle. But side, side angle is a little bit different. Side, side angle. Alright? That is my case which they call the ambiguous case. Because side, side angle, if I have the side and I have a side and I have an angle, I could have no triangles. Doesn't make a triangle at all. I could have one triangle, only one, but I could have 2 possible triangles to do that. So side, side angle means I have this angle, I have this side, and I have that side.
Wait, what is that?
Side, side angle. I have this angle, I have this side, and I have this side.
But why doesn't the triangle connect?
Alright? Because there could be different possibilities for depending on what I have. So this is the side that's flexible. Alright, because I don't know what this angle is, I don't know what this angle is. So this side here actually can move. It could be here, it could be here, it could be here, and so on. So what do we do to be able to determine if that side moves, and where does it move? Well, I make a right triangle. Okay, I make a right triangle. This is the shortest side that could possibly be, the shortest length that side could be for that to be a triangle. Any other triangle is the side would be longer than that. So I want to compare this side to this side. Well, how do I find this side? If I know this angle, I know this side, and I want to know this side. Well, I would use sine of A equals H over B. To get this here, this height equals B sine A. That would give me a value. Right? That would be the shortest length that we could possibly have a triangle. So when I calculate this, and I find out that, let's say this is 5. But this other side that I have is 2. Well, this side is just dangling here in midair. It doesn't connect to the other side because this angle is fixed right here. It doesn't touch. If that opposite side is shorter than B sine A, we have 0 triangles. It doesn't form a triangle. Okay? So if they give me 2 sides and an angle, I am going to check to see, all right, do I have a triangle that's formed? All right, let's say that A is longer than that value. All right, if it's longer than that value, all right, and we know by a right triangle, if this is my right angle, my hypotenuse is always the longest side, correct? So it's going to connect someplace out here. So it could connect here, or it could connect here. This side could go here, or it could go here, one or the other. Well, if A is greater than B sine A, and A is greater than B, I have one triangle. So if this side here is bigger than this dotted line, okay, that means I could have 1 or 2 triangles. If A is bigger than B, I can't swing this back over this direction because it will actually extend further than the triangle. So take for instance, this was B. I could not bring that back over here and connect to that angle because it extends past that side. So that way that this is the only triangle I can get. And we'll tie this all together. But this is the concept. This is the concept that you need to remember.
That's a funny face, Gabby.
But you gotta remember, this side here is on a hinge. It's just like the door. Right here. If this side is longer than this length here, can I actually shut a door?
No.
No. That door has to stay out here. And that's what that side is doing. I can't bring this side back over here because it does not fit. So here it is. If this opposite side is bigger than B sine A, and that opposite side is bigger than the other side, I only have one triangle. That's what you have to study. That's what you have to memorize.
So when is the pie and everything gonna get thrown into this one?
We'll see, use the principal values.
Two triangles? Who would have thought? Look at me. You see that, Blair? You saw that. You see that, Shane? You saw that. This is why we're glad you guys are seniors.
If A is greater than B sine A, and A is less than B, we have two triangles. Because now I can swing this side back over here and have this small triangle or have this big triangle. I have two triangles there I can form.
How can you form a big triangle when the side's smaller?
If A is smaller than this side, but it's longer than this, all right? A is bigger than B sine A. This side can touch on either side. It is still shorter than this. All right, it can flip back, slide back and forth.
It's like a door. We got you now.
So that's why this is called the ambiguous case, because we could have three different options. All right, so we have this triangle here. Let's go A, B, C. So this side is called what? B.
Good job, Garrett. That's the right thing.
I'm sorry, I just got to go
Did you say D?
I said A, B, C, and D, yeah.
Yeah.
But it sounds like the same thing, it's D for boy.
Good cover. All right, we have an angle, side, angle. There's only one angle that C can be.
Oh, 70?
70 degrees.
Good man.
Big math.
So now we can set up our proportions. All right, sine of 25 is to A, so this is A. Sine of 85 is to B, as sine of 70 is to 10. Always the angle, sine of the angle over the side opposite. Now I don't have to worry about this here, because this here is only when I have side-side angle. That's the only time I have to worry about that. Every other case, I always only have one possible triangle. So we're going to set up two proportions. So we always want to find the unknown, so in every ratio proportion, I only want the one unknown. So this one here, sine of 85 over b equals sine of 70 over 10. Make sure our calculator's in degrees, because we're going to be dealing with all with degrees here. So this is 10 sine of 85 over sine of 70 equals b. Cross multiply. And then we divide. So we got 10 sine 85 over sine 70.
Shoot. Who said that it sounded like a recording? Is that you, Garrett?
What?
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 Huh?
Pardon?
What did you say actually? Like, I
Ten.
actually.
10.6.
10.6. Gabby says 10.6.
I bet you Gabby's
The
wrong.
calculator could be wrong, you know.
The calculator could be wrong, or it could be an
Actually-
operator error.
Okay.
Wrong answer, it's actually 10.6.
What is
Divided by sine 70.
Alright, we're rounding everything to the 10th place.
I got 10.
We round everything to the 10th place.
Me too.
Oh, I didn't put, I put 70 instead of 85.
Oh my gosh.
You got scared, didn't you, Gabby?
Not really.
Alright, then we do it again with these two ratios. Sine of 20,
2.6.
sine of 25 over a equals sine of 70 over 10. So we get 10 sine of 25 over sine of 70 equals a.
See, I'm really happy right now, Mr. Bolton, but I know you're gonna hit me with a curveball here soon. So,
We get
please hold on.
10 sine of 25 over sine of 70.
Hold on, sir. So impatient.
10 sine of 25 over sine of 70.
4.49. So 4.5.
Now you can check to see if you're reasonably correct, because the largest side is always opposite the largest angle. One of our geometric principles. My largest angle is 85, is 10.6 my largest side.
Yes, sir.
Yes. My middle angle is 70, is 10 my middle side.
Yeah.
And 25 is my smallest angle, is 4.5 my smallest side.
Yes, again.
Yes. So therefore, most likely we are correct.
Most likely. Wow, how could we be wrong if the facts are the facts?
Well, we still could have a smaller side, but the wrong side number. But most, if you did your math right, you should be correct.
So when does this get squared?
So then he's gonna add in the pi over 4 things. We're gonna have to figure out how to do it on a graph. Do we have to do it on a graph?
No.
Really? So we're gonna have to use pi?
No.
No. We
Do we
didn't,
have to
what?
do anything with the values that we
No.
Oh my
Is
goodness.
there new values?
Watch him give us 60 more now. I guess those are kind of values, that A is less than B sine A, no triangle.
There's only 3 of those.
Alright, so here we have this triangle here.
You're not one.
This is the first time I've actually written everything down off the board.
Wow.
Alright. So when you look at these here, these cases here, you gotta remember that your letters are not always gonna match. What you need to remember though is that you're always comparing the side opposite the angle that you're using. Alright? Because you see sine A and lowercase a, they're the same. The other side would be by itself. So here we have angle A is 36, A is 2, B is 7. We have side angle. Here's our special case. So we need to check to find out, do I have a triangle? Or do I have 2 triangles? Or do I have no triangle? Because I don't want to have to do all the work if I don't have a triangle, because it won't work. Okay? So my key is, I'm not using the side opposite this angle, which the side opposite this angle is 2, so I'm not using that. So I'm going to take 7 sine of 36.
Why are you using the sign opposite?
Because that's what we're going to use to compare. Remember, it's always the angle and the side that's not opposite.
Well, since we already have a lowercase a and a lowercase b, we already know that it is,
We want to compare it to
it's two triangles.
this. We want to compare it to this. We have two sides, but not necessarily two triangles.
But if a is less than b, on top of that, there will always be two triangles.
No, but this has to be the case first.
Ah, okay.
Wait, could you explain like the 7 not clear again?
Again, here's my principle that I'm comparing to. Look, every time.
Okay,
B sine A.
B.
It's not A sine A,
it's B.
it's B sine A.
Okay.
It's not Ashton Kutcher.
So therefore, I'm not going to use the 2 with it, because that's opposite this angle. It would be the same thing if this was C and this was lowercase c. I'm not going to use the 2
You're gonna use.
with the capital C.
Okay.
I am a C. I am a CH. I am a C.
What is sine of, 7 sine of 36?
4.1.
1, 4.114. 4.1.
4.1.
Love Jesus eternally.
Okay. For it to be a right triangle, that side opposite has to be 4.1. That's the shortest it could be.
The shortest.
So now I compare.
A is smaller, so it's not a triangle.
A is smaller than this, so therefore no triangle.
Wait, a is
That's-
smaller than what?
Then the.
A is smaller than this,
Yes.
so therefore no triangle.
No triangle.
So I don't have to do anything more.
That's just the cat's. Wait, what is that? What's the saying? That's just the cat's meow, right? What is that?
Last part.
No, what's like? That's just like the cat.
I've never heard that.
We don't know what you're talking about, Isaiah. You're crazy.
It's a saying. Like, what's always really, really nice. Like a nice picture.
Alright, so here's again. We have angle, side, side. So we got the two sides and the angle, so we have to double check to make sure, do I have one triangle, two triangles, or no triangles? So Benny, which ones how am I gonna compare?
The small b.
Just say lowercase. Come on, Benny.
Just give me in numbers. Just give me in numbers. Alright, how am I gonna do this? It's B sine A. How am I gonna do that?
So 17 and 82.
Alright, you remember, this is B. Is this opposite of A?
No.
No,
Are they the same letter?
no.
Okay? So when I go here, do I wanna use the same letters?
Oh, no, so 15 and 82.
15 sine 82 degrees. Alright?
I got you.
There's the key. I don't want to use the same letters.
It is 14.85.
Why is it 15, not 17?
Alright, I just said it. Let me repeat myself again. I do not want to use the same letters.
Yeah, I know, but why is it, if we use the same, why is it 15, not
That's
17?
C and B.
Are-
B and B.
Which ones are the same letters?
B?
17 and 82. So do I want to use 17 with 82?
No,
Because
it's the same.
they're the same letters. I don't want to use the same letters. Alright, 14.9. Now I will compare. How does the side that I have compare to this?
It's less.
Side that I have compare to this?
Oh, I mean it's greater, Sasha.
It's bigger.
It's bigger.
So it's either this or this.
Okay, so now what we do?
Then I compare these. How does this compare to
It's
this?
greater. So
Alright.
it's one triangle.
So here it is. This is bigger than this, and this is bigger than the other side I've given. So I have one triangle. So now I can do sine of 82 over 17 equals sine of A over A, which equals sine of C, which is over 15.
So we're doing A first. Or
No.
we're doing C
Wait,
first.
B
Doing
is
C
greater
first.
Excuse me?
B is greater though.
Do you remember, these letters would not always match with the letters I have.
Yeah.
Alright? This
These have to be
saying
A's
here,
scenario.
the side
Okay, so
opposite,
17 is greater than
Alright.
14.9.
the saying the side opposite here,
Mm-hmm.
how does it compare to the side that I'm given? So here's the side opposite. How does it compare to this?
It's greater.
It's bigger. The side opposite, bigger than the side I'm given,
Alright, yeah.
one triangle. Alright, you can always look at it this way. The side opposite, how does it compare to the side that I just used? Alright, the side opposite is bigger, so it's one triangle. When I look at my proportions, I don't want to use this yet because I have two unknowns. I always want to use the two ratios that will only give me one unknown. So sine of 82 over 17 equals sine of C over 15. That's 15 sine of 82 over 17 equals sine of C. Anytime I'm looking for the angle, I'm going to do what on my calculator?
That I do not know, I have no idea. Oh, arctangent.
Arcsine.
Arcsine.
But
Did I say
you're right.
arctangent?
Yeah, but you had the right idea.
Not the right, missed it by awesome.
You had the arc part
It's a
right.
struggle today.
You had the arc part right. So we're going to take the arc sine of 15 sine of 82 divided by 17 to give me an angle.
I got 60.8. Well, no, 60.9. Sorry, so 61.
Now always round to the 10th.
Always round to the 10. Yes, sir, yes, sir.
Would everybody agree? 60.9? Garrett says 62.
Yes.
You do arc sine, then you do parentheses, 15, then you do sine 82, then you do parentheses, then you do the divide line 17, close parentheses, and you hit equal. And you get 60.89926.
Did everybody else do it? Everybody agree?
I got that.
You got that? You got that? Okay, 60.9. Alright, so now I know 82, I know 60.9, can I find A?
What?
Can I find angle A?
Yes.
Alright, how do I find angle A?
Two angles are right.
So how do I find angle A?
You just subtract from 180. You do
Subtract from 180.
60.9 plus 82 minus 180.
Which is?
142.9. So you would have 37.1. 37.1?
Yeah.
Please do remember that when you write your angles, you're gonna put the degree symbol with it. That is your
I
answer.
put degrees Celsius. Chemistry.
Alright, now I got my other angle, so now I can do sine of 82 over 17 equals sine of 37.1 over A. Cross multiply, A equals 17 sine of 37.1 over sine of 82. Which is?
Let me finish writing down this problem. I still wanna know what number sine uses when you put it into the calculator, so you can calculate it on paper. Will you ever tell me?
Do what?
When you hit function sine, what is it doing to that number?
It's finding the ratio of the opposite side of the hypotenuse.
10.4.
So how do you do that on paper? How can you can you prove that the calculator is right?
No, you don't wanna go there.
Why? Can you,
You had a hard enough time with this.
I'm not having a hard time with this. I wanna,
What did we get?
10.4.
10.4?
can you teach me one day? Can you teach me today during some period? I mean, I really wanna know, like, I'm genuinely curious how it works.
Well, you would actually have to know the sides.
You have
Go
to know
over
the sides?
Go over the
But how
angles.
does it know the sides? What is the
Because
base number they use?
Before we had calculators, there used to be a big table
Uh-huh,
with all the angles,
uh-huh.
with all the sines, cosines, and tangent values. So you know how we know that sine of 30 is 1/2?
Yes.
So on that table, it has sine 30, had 30 degrees, and the sine would be
You mean
1/2.
sine, you mean cosine
0.5.
30, you mean cosine 30 is 1/2.
No, sine is 30, 1/2.
No, sine of, oh, cosine 36, power 6, my bad, sorry.
So you would have 0.55, you would have 0.5000.
Uh-huh,
And then you know the cosine of 30 is square root of 3 over 2,
mhm,
and they would have that value too.
uh-huh,
But then, all the other ones, they have calculated through algebra of all those values, so they put it all on a table.
mhm.
Well, they put all that in the calculator, so your calculator comes together for you. Basically, that's how it works.
Mhm.
Oh, so A is 10.4. So we have A equals 37.1, 10.4. B equals 82, and B equals 17. C equals 60.9, and C equals 15. So again, want to check smallest angle, smallest side, biggest angle, biggest side. So we're probably correct.
What about the middle?
That's.
So if the big angle is correct and the small angle is correct, the middle angle will be correct too.
Amy, you have really long hair.
I'm planning to cut it.
Really? Don't cut it. If you're gonna cut it to your shoulders, that'd be so epic. I mean, if you're gonna go for it, might as well go for it.
All right, let's do another one.
I might just buzz all my hair off tonight.
You see it every day.
I'll do it tonight.
Do it.
No.
He's not gonna do it.
We all do that.
Imagine how weird that would be.
If I lost a bet, I would do it.
Right.
Yeah.
What can we bet on?
Sorry, right.
When have you ever won a bet against me, Gabby?
To see it with your hair.
When have you ever won one?
All right, so here we have these. All right, so we figured out how we would see no triangle. We figured out how we would see one triangle. So let's see if we can figure out what we would have to do 2 triangles.
Ooh.
All right, so Gabby,
Okay.
what would we do? What would we multiply to use to compare?
17 sine 36.
Very good.
Atta girl, Gabby.
Ah.
Are we ever gonna use cosine or tangent, or is it always sine?
Law of signs.
Oh yeah, law of sine. Yeah, I got you, bro. I forgot
Other
what the.
law of
It's 9.99. That's 10.
It's 9.99. So do you want 10?
That's fine. 10.0.
There is, there it is.
Okay.
Are you okay, Blair?
I wrote down 36 or 37 instead of 36.
So Garrett, what 2 sides are we going to compare? Or what side are we going to compare?
The C.
All right, so 16 and 10.
Yeah.
All right,
The one you didn't use.
so it is,
It's less than. New side you go. Wait, no, it's greater than.
it's bigger than,
It's greater than.
okay?
It's less than.
So it's 1 or 2 triangles, correct?
Mm-hmm.
All right, now we're going to compare it to here,
Mm-hmm.
less than or greater than?
Less than.
Less than, so therefore how many triangles?
2.
2 triangles.
2
Look at that.
is for the way the
Can you say it
triangles
again?
form.
All right, do my sine 36. The side that I didn't use, I'm going to compare,
This is weird that.
it's greater than,
Oh, weird being like a way
okay? A is greater than, A is greater than.
Please. What's it on your
one
left
triangle,
hand?
two triangles. Then I can compare this to the side I'm given. Alright, and I see the side is smaller. A is smaller than B, two triangles. Okay?
Yeah, it shouldn't be a big version.
Still using the law of signs. Sine of 36 over 16. Sine of A over 17. Sine of B over B.
And then no one looks good.
Garrett, you look at me like that every day.
Dirty dog. I like the dog ones.
Okay,
Next
So-
one.
then use this proportion first, correct?
36, 16, 17, 30. Oh, goodness me. Whoa, chill. Which one are we? Oh, I see which one we're looking at.
38.6. Think if I did that right.
Wait, is that 16
That is 16.
for the dotted line?
Yes.
Yes. So remember, two triangles, we could have it extending out, or we can have it coming back.
Oh, so that's not the 90-degree one.
YouTube is just gonna
I
run.
keep finding degree Celsius.
Definitely just scared.
Me too. I'm glad I'm not the only one. It's because of math today.
What?
Or not math, chemistry. Well, I mean, it was math, but chemistry
What are you
today.
talking about?
I keep writing degrees Celsius. Me and him both.
Alright, everybody agree, 38.6.
Have I checked it? No.
I
Let's check up on Gabby here.
You probably should. But I mean, I think it's
She's
right.
been doing well today.
I'm
Today.
correct.
I don't get a compliment for second grade.
It's
No.
38.6.
You see my
That
eyes?
is true, you are doing very well today.
You see my eyes the whole class.
Yeah, I have.
Monumental.
It is.
It's 38.6.
38.6.
I mean, 38.65, but whatever.
Alright,
It's not.
so,
Yeah, because it's 4 7.
Oh, yeah.
Yeah.
if you notice,
Is it actually 38.7?
38.6, 38.7.
It's, well, it's 38.647.
Alright, 38.6.
So you can just round it to the 6th.
Alright, if you notice, if the side is this way, this angle is acute.
Acute.
Not ugly,
Acute.
but acute.
Not what?
Not ugly, but acute.
Not ugly, just acute.
Alright,
It's not Isaiah.
but if you notice when you put this back here,
Go back to sleep.
this angle is obtuse.
Obtuse.
Alright?
Obtuse.
We also want to remember, where is sign positive?
No, no.
Wait, time out.
No.
What do you mean that's obtuse?
It's bigger than 90 degrees.
I told you
What-
to go
what
back to
is?
the values.
This angle right here.
Oh, the small triangle.
Yeah, this one triangle.
Positive in the first and second.
Alright, positive in the first and second.
Why are we doing this? I thought you said we
Alright.
didn't do this.
Because remember, I got two triangles.
Okay,
Alright? But the only reason I'm doing this is to illustrate what we do to get that second triangle, or that second angle. If this is 38.6, this is 38.6, but I want that angle.
Oh, yeah, you do.
You could have just talked about supplementary and complementary. You didn't have to pull out this. It's scaring me.
How do I find that?
When
You subtract
From
180.
180.
Okay.
You took geometry, you know.
Huh?
You took geometry, you know.
So to find the second
Still.
value that A could be, I'm going to take the angle that they gave me and subtract from
180.
180.
180 minus 38.6 would be
40.
41.4. 141.4.
141.4 degrees.
So, and the reason you have two triangles is
Oh!
because.
Because of
Oh,
our
wait, never mind.
identity.
Just kidding.
because of our identity.
Just had to say it out loud.
Alright, so, I know what the angle could be if it's over here. Listen, I know that the angle is over here, and now I know what the angle is over here. So now I need to know what the side is when I have this angle, and I need to know what the side is when I have this angle.
Wow.
Okay? So therefore I'm going to use this trig value ratio, which is sine of 36 over 16 equals sine of b over b. And if I'm solving for the letter b, that's going to be 16 sine of b
What would be arctangent?
over sine of 36 equals b. Now I didn't put any numbers in because I just want to do the math once. So now I'm just going to do 16 sine of 38.6 divided by sine 36.
Wait, time out. What did you just say?
What?
What happened? Why did we leave the B in there? Backtrack.
Oops, I'm sorry, I did that wrong.
Oh,
'Cause we gotta find out what angle B is.
yeah.
That's what we wanted.
All right, so I got angle A,
Yes,
or angle C is 36.
yes,
A is 38.6.
yeah.
So B is what?
Oh, B? 38.6 and what was that one? 36?
36.
So that is 74.6. So you just subtract that from 180 and you get 105.4. Because it's 7, yeah, it's 105.4.
Yeah.
Why, you didn't believe me, Mr. McLaughlin? I just did the math out loud for you.
All right, or if A is 141.4, what is angle B?
That would be 38.6. It's 38.6.
No.
141?
141 plus 36 minus 180.
Oh, 131 plus 36. That would be 177.4 minus 180. So that would be 2.6.
How do you do that? Wait. What? What did you just do?
Mental math.
Ah, you can't do that.
All right, remember, if C is 36, A is 38.6, we're gonna take those two and subtract from 180, we get 105.4.
Yeah.
The 36 minus 38.6.
No, 36 and 38.6 from 180 is 105.4.
36
Remember-
plus 38.6 minus
All right.
180.
Remember, angles of a triangle add up to equal what?
So we did
180
180. If I know two of them, how am I gonna find the third one?
by adding them to the subtraction.
Okay. Here, 36 and 141.4, subtract from 180, should be 2.6.
wait.
So now that we know that, we can plug it into the 16 sine B equation, correct?
Correct.
So we have to plug in both though to find both possible for both sides.
16 sine of 105.4 divided by sine 36 will give me my B.
So wait. Where did we get the 2.6?
You have to add the
36,
141.14
Okay.
and 2.6.
Okay.
16.98, so.
17?
Yeah, 17.
What did you just, what was that one for?
Let's keep it in
No,
16 point.
9.
Which one was that one for,
Give me the second decimal.
8.
8.
Gabby?
What?
What, did you use that one
Oh,
for
one.
the,
Oh, wait.
for the
what did we
105
do?
or the
That's not
2.6?
right. We-
Because with the 105, I got 26.24.
Well, I screwed it up.
26.2.
Yes.
Yep, that's closer.
All right, then we do it again with the 2.6. 16 sine 2.6 divided by sine 36.
16. Who needs water? The kids in Africa? Yes. Oh, Mr. McLaughlin does need some water. Drink some water, Mr. McLaughlin.
Did you
Oh,
get 1.2?
hold on, I put in 16 instead of 36. I caught my error before I said something, Jack.
What?
1.2.
Yeah.
1.2?
Yeah.
What are you writing there? Oh, that's a lot of
Well, I know-
stuff.
So that means B equals 26.2. B equals 1.2.
What was the answer?
Oh, so one of the answers was 26.2 and one of the answers was 1.2. But we have to do the whole since it's double.
There are two answers.
So these two triangle problems take a long time.
Alright, so what we did, we actually find the two triangles. The C and the C didn't change, so they're the same. The angle A and B does, so these two sides, this side does too. So again, we want to check. Biggest angle, biggest side, yes. Smallest angle, smallest side, yes. Biggest angle, biggest side, yes. Smallest angle, smallest side, yes. So here's the information I would need for those two triangles.
That's crazy.
Alright, so if I have two triangles, alright, if I have two triangles, when I find that first angle, how am I going to find the other option for that same angle?
You subtract.
From
180.
180. And I'm going to use those two angles to find the other two possible angles. So again, we got 38.6, so we subtracted from 180 to get the other possible angle. And then I took these two angles, subtracted from 180 with this angle to find the other two angles. Alright, so we'll work on that some more on Monday. What I'd like you to try to do this weekend, let's do 1 through, on page 439, 1 through 7, odd, and 13 through 17.
Yeah.
Alright, page 439, 1 through 7 odd, and 13 through 17 odd. We'll work some more on it Monday. Have a good weekend.
Hi, Reagan.